Yeah.
Next one, 18. 18 is this. How did you do 18? Do you remember?
For 18, I did like a over 9 pi equals 1 over 9, 1 divided by 9 pi divided by 2 pi. So then a equals 2 pi divided by 9 pi times 9 pi. So a equals 2 pi.
Yeah, that's why I saw that you won 9 pi. This is all right. This is the fraction, right? This is the
Yeah.
fraction, right? And then you should time 9 pi. That's the
Yeah.
total area, right? So this one is actually 1. You flip it and you can see it's 1 over 18, right? Times 9 pi. Which is supposed to be pi over 2, right?
Yeah, sorry, I just tried to like flip it, but I think I should have just done 1 over 18 pi rather than 1 over.
Yeah. Right. So we categorize this into, we do it step by step, right? I think you'll be okay, right?
Yeah.
And the next one is 28. 28. 28, I think it's a little similar mistake you made with 20 with 18. Because you're familiar with the fraction form, right? You're still using 120 divided by 360, right?
Yeah.
And then time the whole area, which is 81, right? 81 pi. Does that make sense? So that'll be
Hang on, let me
3.
go back to my original work.
Right.
28. Okay, 120.
28. 28.
I did like a over.
Wait, 28 is here. Oh, I know. You are just get confused with multiplication or division. You're supposed to use that 81. You're using cross product, right? Are you? Are you using cross product?
Oh, sorry. It shouldn't have been. I think I just got it wrong. I think I was reading my own stuff wrong. It should have been 1 over 3 times 81, not like
Yeah.
3 times
Yeah.
81.
Yeah.
Sorry, I think I just misread my own thing.
Yeah. So, well, cross product, this kind of fraction. Well, that's a place you can find mistake. Just be careful. Whenever a fraction happens, we should be careful, right? When we change the denominator and numerator, we always get confused if we do too fast sometimes. It's 28. The next one is 51. Let's see, 51. 51. It's 50. Oh, 51 is also, it's definitely in the syllabus in SAT math, but this is the highest, this is probably one of the most difficult questions, is 51. Everything you know, but I just take step by step. Do you remember this?
Yeah, I remember I had a hard time with it. I just didn't really know the answer.
We have to just do it a little by little to see what we can do. It's not that we can do it directly, so we might do whatever they gave us. So this is a 5 in here, and there's a 20 pi. See, in the shaded sector they gave me, I can find the angle of that arc, right? I can find this angle. Does it make sense? Because we just did several questions like that, right? Before we go on about their question, I can find my angle, right? Can I find my angle? Does that make
Uh,
sense?
how do
Okay.
you? I don't understand. What do you mean? Oh, wait, because a equals 1 over. Hang on, can I
Yeah,
try to
yeah,
do it
that
again?
fraction. That fraction is very popular. Yes, yes. Oh yeah. Oh, you're using this formula. That's good. That's even better. Probably quicker. That's very nice. Yeah. Yes. So now we know that one is 8 pi over 5, right?
Yeah.
Let's keep reading a little. So the arc of the sector, and then let's just find Mn. If I want to find Mn, maybe I can find. Well, Mn is definitely in this triangle, right? Within that triangle, isn't that something related to my 8 pi over 5? At least I can find this angle, right? If I know the angle, I might have a method to find out, right? Does that make sense? Does that make sense? If I can find, wait, if I can find the other angle, MON, what's this angle? So I can know more about this triangle. What this angle? How do you find that angle? Remember, we just find this one is 8 pi over 5, right?
Yeah.
What is this angle then?
It's 2 pi minus 8 pi over 5.
Yes,
Oh,
yes.
it's 2 pi over 5.
Yes. Yeah, it's 2 pi over 5. And now if it's 2 pi over 5, if does this ring a bell? If I know that angle, how do I find that L?
I don't really know.
Okay, if this point, this is a very typical question. After you learn, I think you will know. Let's just take a look at ABCD, see whether that helps. See, ABCD all relate to, forget about the constant number. It's all a sign about pi over 2 or 2 pi over 5. Pi over 5 or 2 pi over 5, right? See, it's kind of related, right? This is half that, right? And also you use sine. If I want a sine of something happen, I must have a right triangle, right? I must have a 90-degree angle, right? What do? I make this. Have you seen this before?
So there's like the 90. Oh wait, you split it into two. You split it into two. Okay.
Yeah, I split into two because they are, isosceles, right?
So this is like pi over 5.
Yes, that's pi over 5. Exactly. Because that two radiuses are the same.
Then we have 90. So then we have
Yes.
pi over 2, and then we can determine like the next one because that's pi. So
Yeah.
pi minus 5. 5. 2, 10.
Wait.
3.
Oh.
Oh wait, this does not help. I don't think this helped me find like.
Yeah, you can just use pi over 5. Pi over, see, they have a lot of pi over 5 happen in here. Can you find, see,
Yeah,
there's
sorry.
sine. Find sine pi over 5.
Sine pi over 5. Okay, hang on, sorry, let me just erase this.
Yes.
Okay, pi over opposite over hypotenuse. So
Yes.
it's like
It is
how oh
this
wait, the
is a
radius
P.
is 5, right?
Yes.
The radius 5. So it's
It's MP, or you can say X. Yeah. Yes. Yeah, I can find MP, right?
yeah.
And then I can find MN, right? Just double that, right?
Yeah, so it's like
Does that make sense? I think I want to choose B, right? Is it B? Now it's either A or B, right? You have to double it.
Yeah.
So it's B, right? Does that make sense? B?
Yeah, it does make wait, sorry, no, sorry. So like why is like where's like the 10 part coming from?
MP, let's just find MP. MP, if I times 5 on the other side, is 5 times sine pi over 5, right?
Oh, yeah, sorry. So
And
then
then
like
double
and then
it.
like MN is and then MN is like twice MP. So
Yeah, and then just double it.
yeah, I see. Sorry, I didn't do the reverse. Right.
Yeah. So this is the, well, if you search around, this is those like the 800 sport level question. It's kind of, it's all in syllabus, but it's a little difficult. So let me just say one thing. In the circle problem, if they draw two readers, and if they ask you this chord, there's a big chance you're gonna do this height. Does it make sense? Saying 80% chance or 70. Does it make sense? Because this is a beautiful line symmetry. Does it make sense? It divide everything in the circle in half, also divide everything in this triangle in half. Does it make sense? Does that make sense?
Yeah, so we divided in half. It's easier to find like the
Yeah. You can I think you should mark. I'm gonna collect all your like all the question that you have problem, and you probably should do the same. So this one should also be inside, right? Especially this one. So if you know how to, it's like those. If we have isosceles, we always like to do this, right? Even though without circle question, right? Does that make sense?
yeah.
Because it would be just there's a lot of, not a lot, well, a few properties there. Okay, that's it for this one. And the other method I said is also a way. When we have this kind of a little difficult or first time strange trigonometry problem, you can just find the angle that provide where are they and find that sign. Sometimes they can give you, well, they can give you a little direction. Does that make sense? We all do that when we meet this kind of like a question for the first time. So this one, I have to say it's a circle problem, but also relate to this kind of isosceles, right? This altitude in here, this height in here. Okay. So there's another way to do this. It's actually the same way, but it's a different angle. It's just when they ask you to find this, it's mainly to focus in this triangle. Does it make sense? So this is how I do it. If they want to find a base, this height is always the perpendicular line here is always the direction. Does it make sense? So if you do this, kind of need this, it's also the same direction. This one okay? Then go on. Next one is 7. Wait, 3. No. Question 7. There's a typo in that question 7, I believe. But that question is something we should be careful though. Let's see question 7. Do you remember this? Let me just change one thing. Here's 5. Let me change that into 5. Maybe you should can you draw 7? Drawing is the key. They got a typo for 7. There's no right answer for 7.
Yeah, I was thinking like for 7, it just doesn't make sense to me.
Yeah, none of them is actually meet their requirement of the information they provide.
Oh wait, sorry. Sorry, let me just go back. Sorry, I wrote the wrong coordinates there. Like I said, it should have been 5. Like it doesn't make sense. Like even if like
Yeah. Yeah, that's a 4, right? Can't you say? Does it make sense?
yeah, so it's 2-1.
Yeah. Just drawing this would be okay, right? Or this could be asking
Yeah, it's
you.
just like the typo didn't make sense. It's like
Yeah.
what the problem was.
Yeah. So this kind of question, I think originally designed to ask you the distance between 2 points, right? You just, if it is not in this vertical line, you have to find that you have to use that x1 minus x2 squared plus y1 minus y2 squared, right? Do you remember this? This is the
Yeah.
formula of the distance. You just use this to let it, check whether it's the same read as 4, right? And you can just test them out for the four of the different answers there. Next one is 8. Wait, 8. What's question 8? 8 is a typo. You would definitely get this one right. This is that's not 34. It's
Yeah, there's just like a
3.
lot of it should have been 3/4. That's what I
Yeah,
was like. I
yeah,
got it right.
yeah.
Like I was like, what? That none of them.
And
It's really
then
tight.
yeah, and then it's 15. 15. You do have 15 day that right about 15. How do you
I
do
was trying.
15?
I was trying to I try to divide it all by
Yeah, that's the right way. Because we always like to x squared and y squared to be the same and 1, right? Coefficient is 1. That's good. I think this one you mean minus, right? Minus 3 over 4y. It doesn't really influence on this.
oh yeah. Sorry. Let me just. Oh, shoot. Sorry, typo.
Mm.
Wait, okay.
Wait, I think I'm with you on this one because that's a x over 6 and yes. It means this is becoming x minus
It's like
1 over 6. Yeah.
it's like 3 minus. It's like this.
This one, on the other hand, is something. Let me think about this.
Oh, 9/64, not 9/81. Sorry. I think I did like a math problem.
Oh.
Okay, 3. Never mind. I think it's just 9/64. Sorry, I think I actually did. Sorry, I think the problem was that I got it wrong math and math. I did the math wrong.
Yeah, that's, oh yes, that's
Yeah, for some reason I thought it was 81 instead of
3 over 8. Yes, and then you square that, that's 9 over, yes, that's good. So now you just have
Okay,
to
hang on.
add all that, I guess.
Okay, wait, I'm trying to figure out the common.
Huh?
I'm trying to figure out how to get make them all have the same denominator.
Wait, I think right now you can just find r squared. You plus this, and you plus this, And you
Yeah,
have
I
this.
know, I know. I'm trying to figure
Yeah.
out how to have them say do the same denominator so I can plus them.
So it's 2/9 before.
It's 2 over 9 plus 1 over 36
Yes.
plus
64.
9 over 64.
9 over 64. Now this one I think it is 36 times 4. Oh, that's a 9. Yeah, that's 2. That's not bad, man. That's good. And that's 1 over 4, which means it's 4. Wait,
Oh,
36 is 1 over 4, and that'll be 16. Oh, that's good. That's 25. 25 over 64, right?
and then divide, and then we square root that, and then we get 5 over 8.
Yes. Whoa, great.
Yeah, I think I just made like a math problem. For some reason, I thought 8 times 8. For some reason, I was like 8 times 8 equals 81 for a second. I don't know why.
Yeah. This is a crazy calculation thing, right? You gotta be careful. Unless you can do it with decimals. I would definitely use this method, but if you throw all this in, they might give you a circle, right? Are they gonna give you a circle? Let me just try it. Have you tried this? Of course, I'm using your method. I'm
Tried
just saying,
what?
I can try decimal. I can use the calculator. Does the calculator give you the whole circle and I can just see that readers on there?
I don't know. I didn't use the calculator. I don't know if we have a calculator on the.
Yeah, SAT now give like a calculator all the time.
Like decimals or
Yes,
like
decimals.
I don't know.
Decimals.
They let you decimals on the SAT?
Yeah. Before they have one section using like decimals, but after they started using the computer to test, they give authority to you just have calculator all the time.
Oh, okay.
So I can just
Dude, we have
find.
decimals through the entire SAT.
Yeah, you have. Yeah. So that's why these days you can see that in the YouTube they have like a saying decimals for SAT math. Yeah. I think they have to recreate some new question to say everything can be solved. Not everything. There are several questions you can't solve. You 36x squared. Wait, where's my square? And plus 36 minus 20 minus 12. Do you have a calculator with you? Do you have a calculator with you?
The calculator? No, I don't have a calculator.
Oh, okay. Too bad. You have they can use it probably too faster. And then it's minus 12x minus 27.
Crazy. I thought you just had to do it all manually by hand.
Yeah, that's normally that's what happened before. Wait, half of them can be done by calculator before, but now this day you can do it with all. But they still save several questions you can't
What?
really do it with calculator. All questions in math can use calculator to do if you
We
can.
can use the calculator for all the questions.
Yes, you can. There are, but they design some questions you can't really use calculator unless you create something.
Unless you like hack it. You hack the system.
No, not hack it. It's just someone is really good at calculator.
I'm
Sometimes
joking.
yeah, but I don't think that's well, that's not very easy though. Minus 12x.
I'm joking. I meant to like find a way to use a calculator to do it.
Yeah, it's actually allowed. Now it's allowed. What do you know? 27y, and I hope they give me a circle, and minus 8. Give me a circle, and it goes to 0, right? See? God. Huh? Can you see it?
Oh wow!
See?
You can just do it.
Yeah, this is crazy, right? Wait, wow. This one is not that helpful. Actually, we went all the way. Because it's a fraction, see? Oh, but I think I can choose, right? I think I can choose the right one. Let me just take a look at the answers. 5 over 8. I think this one we still have to do with the algebra, right? I don't want to go all the way to, I can't really, unless to give me something. I don't think so. Does that make sense? See, this is still we have to use the traditional way, right? Right, but it's good to know that we can draw this, right? If it is, it's kind of some integer that we can totally do it, right? Does that make
Yeah.
sense? No. So this
Yeah,
one,
that makes sense.
yeah.
I think that like it helps more to like do it like this. So like I feel like the fraction, but
Yeah, fraction, you can't really know this, right? You gotta use a little extra time to test, which one is right. So that's not worth it then. Okay, next one. Let me see the next one. I think that's the last mistake we made. Let's do some little questions that last time we did what question? We did a tangent question. Do you remember that one? Do you remember?
a what question? A tangent question? Oh,
Tangent
like
line. Tangent line question. Do you
yeah,
remember?
yeah.
So I want to. You understand all that, right? Did you review
Uh,
it?
kind of.
For example,
I feel like I'm a bit rusty on geometry.
yeah, that's why I extend all this. So this time we're going to give you a little hard geometry question. For example, this one. This is still tangent line.
Okay, what were the rules of the tangent line again? Okay, so, like, I'm kind of lost.
Yeah, that's the. Because remember, in tangent line, I didn't really prove it was, but I told you this looks like a 90-degree angle. Remember?
Yeah, it does.
Also, this looks like a 90-degree angle. Also, that's a theorem. It is 90-degree angle. Does that make sense?
Oh, okay. So then this is 25 degrees, 25 degrees.
Yeah.
And then so 180. Is this like a rule for tangents that like if you have two tangents, then it is
Yes.
something
Yeah.
90-degree angle?
Yes. You just
Well,
deduce
is this
yourself.
actually a rule?
Yeah. There's. Well, it's technically it's not a rule, but it is. This is just the two tangent line. They intersect with the at a one point outside the circle, like at a external point, and you always saying these two are the same, and the angles are all the same here. This is all the same, and this angle are all the same, and this of course is 90-90. It's basically this line. This one is the line symmetry. Doing this. Sometimes they also ask this
I don't
like.
get it perfectly, but I guess. So like whenever this is like a universal rule, like whenever like there are two tangents, they're
Yes.
going from one point
Yes.
in the circle to like another point, they're going to create like 90-degree angle.
Yeah. We can totally prove it.
See,
Yes, that's D. So now you just remember the second thing or the third thing. The first thing is the definition, one and only one intersection. Yeah, one and only one intersection. The second thing is 90-degree angle. You have to memorize it. Because they didn't ask how to prove it. I can totally
one
prove
and
it.
only one sorry, what do you mean by one and only one intersection?
Because
Oh
the
wait, it's
tangent
only.
line is a definition is one and only one intersection with the circle.
Yeah. Yeah, I think.
This is gonna be very useful actually, even in AI. The tangent line is gonna be something tremendous like a extremely
Okay, well,
important.
so what's your second? So the second one is like the
90-degree angle. 90-degree angle. The radius and the tangent line. Of course, when I say radius, is the radius between center and that.
So the radius and the tangent line always form a 90-degree angle.
Yes, 90. That one. This is the most popular question. 90-degree angle.
Why though?
Why? You want to explain? Okay, sure. Let me just prove it. There's normally two ways to prove it. The second way is a little too much algebra. I have to make a lot of things, but the first one is not that bad. For example, let's say this is not 90 degree. It's gonna be a new method you learn in the future. But now, did you say it's not 90-degree angle? So I can draw a 90-degree angle, right? Let's say I can draw a 90-degree angle like this. For example, this one is C, meaning this one is D. Just remember, from the point to make a 90-degree angle in here, this is supposed to be the shortest distance. Do you remember? If I make something like this, it should be shortest distance between
Like the
that point.
center to like a line is like
Yeah,
the shortest.
from a point outside that line, you draw a perpendicular line, and this segment is going to be the shortest one. See, all the other one is hypotenuse. Of course, this one is shortest, right? See, all the other one, all the other one is this hypotenuse because they form right triangle, right? So if this one OD is the shortest, right? Does that make sense?
Yeah.
If OD is the shortest, then there is a problem. See, OC is already radius, right? This one is already radius.
Yeah.
If you are if OD is the shortest, which means OD is less than OC, right? And OC is
So it would be
R.
less than the radius. So that's like that. It can't be less than the radius. It's impossible.
Yeah, that's the thing. If you less than the radius, which means you are definitely inside the circle, right? Which means my C is in here, and your D is must inside the circle, right? Does that make sense?
Yeah.
If your D is inside circle, if I connect these two and expand that, they must intersect with another point on the circle, right? There's a point on the circle, there's a point inside the circle. If you expand that, there must be. So which means there is going to be, let's say CD, let's say E. E is another point in a circle. But this is impossible. Why? Because your CD is also my tangent line, right? See? Your CD is my tangent line. Because C is on the tangent line, D is also on the tangent line. So your CD is the tangent line itself. But you should supposed to have one and only one point of intersection. Now you have two. C and E are both. So which means our assumption that you can draw something like this, which is the shortest distance or perpendicular distance, which is impossible. That's a wrong assumption. Does that make sense? Does that make sense a little?
Yeah, I guess.
Why is this wrong assumption? Because there is no shorter distance. This one OC is already the shorter distance. So if this is the shortest distance, it must be the perpendicular line. Does that make sense?
Yeah, that makes sense.
Yeah. Also, if you draw, it all look like that. You know, whatever circle you draw, you see? See? 90-degree angle, right? And there's we can also use another way, totally algebra way to do that too. So anyway, now I prove it. It's definitely 90-degree, right?
Mm.
I have a backup method, but it just take a little long time.
All right, we can move on to another question.
Yes, so this is, you have to remember this. 90-degree angle. And we're using that again. This is also a real question in the test.
Okay, let me. Okay. You. Thanks.
Yes, very nice.
Okay, so if this is 20 and then Does the quadrilateral have all like? Oh wait, no, that's a rectangle. Okay.
Oh yeah, those two are, yes.
Okay. What would this be?
And we don't know. Of course, we don't know. Just remember, last question we did, it's a similar shape. It's just saying everything, they split in half by QS, right? Which means this and this are the same. Does that make sense?
Okay. So is this and this the same?
Yes, because this triangle and this triangle, they are actually congruent. They must
Okay.
be.
I feel like I should find the angle and then I should find like sine or cosine or something like that. And then
It
I
won't
could
be
find
that
like
difficult. Well, that's also one way to do it, but it's not to those level yet. Because
okay,
because you haven't used parameter.
oh wait, this is also like the radius, so it would be 20.
Yeah, there's another 20 there.
So 20, and then this is something. Oh wait, okay, wait, 20 plus 20, 238 minus 40
Yes.
equals 2s. So like
Yeah.
2s5.
Yeah.
So then minus, okay, hang on, let me do. One. So Sx equals 99. 99. And then we do the Pythagorean theorem.
Yeah, that's the way. I think
Yeah.
we're good to go. Just leave it there. As long as you be careful with the calculation, that's good to go. Yeah.
Yeah.
呢個
Yeah.
整嘅獎，所以
Yeah, I think I just assumed, I think like for some of these problems I was doing them, I assumed there was like some big theorem I didn't know. And like,
So now let's just prove all the things about this ice cream shape. This is a two tangent line look like ice cream. Right? So what we know is, let me just prove one last time about this. It's just see, this is a 90-degree angle. This is a 90-degree. This is the same R. This is the same R. And this is the same hypotenuse, right? This is the same hypotenuse for both right triangle. So this one must be the same. Saying this one is x, this one must be also the x, right? See, I have like a length, angle, length. So this two triangle must be identical, must be congruent, right? Does that make sense? So everything about this basically split in half by that the middle line, right? Does that make sense?
yeah, okay.
Okay, so this is the thing you have to remember. This is the same. This is the same, and this is also the same. This is also the same. There's a lot of same stuff in here, right? So this is the way to go about this. That's the second thing, or the third thing we learn in tangent line. And there's because the last time you don't remember.
Oh wait, what's the third thing we learned in tangent line? Sorry, could you repeat that?
Third thing is basically the ice cream. Is basically this what I
The
just
what?
described. This is the ice cream. Does it look like ice cream? Everything.
It does.
Saying
You
this
mean
is
the
X.
a cone?
Yeah, kind of a cone. Yeah, this is X. This is X. This two X. This two length is the same. Is the most well? Is the most in this two tangent line question.
Oh, so you mean like when two tangents like come to the same line,
Yeah.
then like and it forms kind of like the conish shape, then they're congruent. Then if we split it in half, it's congruent.
Yeah. This two sides is the same. It's also kind of popular in this kind of two
Okay.
tangent line problem. And of course, sometimes they even ask you about this, like for example, sometimes they ask you about the area of this. I think you can do it because, well, we're gonna get this question, not now though. I can make one because it's easy to see. I got everything. Does that make sense? See, if I know this size, I know this size. I can know the angle, right? If I know the angle, I can know this angle, right? If I know this angle, I can know this sector. Does it make sense? I can know everything. If I know the sector area, then I can just find the area in here.
How do you know the sector by knowing the angle?
Well, because, for example, if I find this one is 30, wait, oh, I can send this. No, just use this one as a back. If I find this one is 37, let's say it's 67 degree. If this is 67 degree, I can just use 67 times 2 and divide it by 360 and time the whole pi r square, right? So I can find the area of the sector, right?
Oh, yeah.
Or you can
So,
use the one that you are familiar.
because you can use that to find
Yeah.
the angle, so you can use.
Yes, I can
Yeah.
find a sector area, right? If I find a sector area, and I can use the whole quadrilateral area just to minus that, and then you can find the so-called a little difficult area in here, right? Because they are not in the formula. Does that make sense? So it's basically not new knowledge. It's just well, this is one of those things you have to use adding or subtraction to get the area, right? Okay, anyway, this is the two tangent line problem. And here is another one. This one is a little tricky if you don't, because this one is actually combined. This is one the star is not tangent line, it's other knowledge. Let's take a look at this one. This is also a real SAT question.
Equals 9. Okay, so circle is tangent. So
Are you familiar with
wait,
this?
this should be like 45 degrees, right?
Well, not exactly. I think you're not familiar. There is another theorem in here. You probably forget a little. But you're drawing the exactly right thing. This is a very traditional shape, which means there's a big right triangle. There's a big right triangle. And then I need this altitude or this height on this, right?
Yeah.
So I don't have to know this one is 45 or not. So for example, if I can just say this one is alpha, this one is beta, this is gamma, I can prove that alpha is actually equals to angle gamma. Does it make sense?
How do you prove this?
It's because I can use 90 degrees. So for example, alpha plus beta, is that 90? So this one is
Oh,
also 90,
yeah,
right?
yeah,
Yes.
yeah. Okay.
And
So
then,
this equals this. I see.
yes, yeah. Because beta, gamma plus beta is also 90, right? So therefore, alpha
And
must
then
equal to
I
gamma.
think like this, I think that
If they are the same, then we will have a theorem which is helping us with the speed a little. Because alpha equals to gamma, so I can find something called, let's say find 10 alpha. There's another way to do this, for example, similarity. Let's just use 10. 10 alpha equals to, I'm going to use this one as B, Let me use the traditional. This one is h height. This one is p. It's one segment, and there's the other part is q. P and q. So tan alpha is h over p. On the other hand, in this triangle, in this right triangle here, I can also find tan gamma is also q over h, right? Is that making sense?
Yeah, and so shouldn't the tans be the same because they're the same angle?
Yes, they're the same. Now I have h over p equals to q over h. Now I have h squared equals to p times q.
Oh, okay. So then that equals to 9 times 4 equals 36.
Yeah.
So h equals 6.
Yes. Does that make sense? So this
Yeah.
is well, it's kind of, you can say that this happens almost basically in all right triangle, right? As long as you have a right triangle, and you must have a hidden, like altitude, hidden height in here, right? So it's there, right? Does that make sense? H squared equals to P times Q. Does that make sense? You can call this as a theorem. Does that make sense?
Yeah.
Yeah. So this theorem is this basically the key is more in here, right? As long as you prove this is 90 degrees. This is okay, right? You have to memorize it. And also, as I said, you should keep a document of your mistakes. You learn way more from them than from me. And this one, I put it in here, not this one. Actually, this one is a little bit, this one is the one that we did it last time. This one is a little bit more difficult. I just want to make sure you remember that m1 times m2 equals to -1, right?
Yeah, that's for like the perpendicular line.
Yes, or like the opposite reciprocal, right? Then you are
Yeah,
okay with 9. We don't have to do it. This one is a little more difficult because you have to test.
I can try. I don't remember.
Okay,
I
you
don't
can try.
remember like geometry that well, like I said.
Okay, let's do 9 then. This one is a little more difficult. You have to test all the answers basically.
Okay, okay,
Wow.
so it's like 130, and then we need to find the slope for this. So
Yeah.
so I guess the slope is for this is -1.
Right. Let me find it. Supposedly use because I must have a center and that one. If it's like this, I can find the reader. Saying this m1, m1 equals to 2 minus -5, and -2 minus 7, right?
Oh right, I keep forgetting about how to do. I feel like I need to always do like in a huge equation and stuff. And then I'm like,
Yeah,
I-
because in pre-calculus like that. But this one is more like a face-to-face kind of geometry. So that's a 7 and negative. So I find opposite reciprocal, which is 9/7, right?
Yeah. So
And
then
then we
y
get,
equals 9/7x plus
yeah.
b. So then what, -5. So y equals 9/.
Oh, that's actually
Minus
better
14.
method than what I have. Yeah, that's good. That's good.
Yeah, so do I just test all the points then?
Yes, that's good. This is actually a better method than what I have. Yeah, that's good. I actually use the slope, but it's basically the same thing. We all have to test use
Wrong.
one of.
Okay,
Yes.
then no, wrong. And then 4 equals, yes, C.
Yes. B. Exactly. So this is the, well, we just have to follow their like instructions, right?
Yeah.
And also they use this M1 time M2. Is also this, not also. This is just the most popular question in like the tangent line. And then well, we basically finished all the tangent line question. Unless the tangent line is totally combined with all the other knowledge, that doesn't really count. We're gonna take you there later, but not now. So I'm gonna give you this as homework, and also wait. Oh, last time, like you were late for 10 minutes. So we can do a little more. Do you have time? Have time?
Yeah, I have time.
Okay. Sure. Now I'm gonna show you one document which is mainly your homework. First, I want to say something about this. This all kinds of marking. I hope it doesn't stop you from doing it, because I didn't really clear them. It's just this is another student. This is one of my students' recent talking about all the mistake she made. She eventually got 800, but this is the mistake she made before. You can just do it yourself, and the one that you have problem, well, just
Could I see the question?
yeah.
EOD. Oh, just try to ignore it. ERE. R. Honestly, I'm not sure how to figure this out.
There is a theorem. Well, we can prove it if you don't remember it.
Is it like
Uh,
is it like 30? Is it also 35? I feel like that could be the case, but like I don't.
30. Well, they ask DRE. Wait, where's DRE? That's R. Oh, that's a blocking. So this is a 35. This is actually double that. I can explain that a little. For
What?
example, let me just say this one is alpha. This little angle is alpha. Is that okay? This is little
Okay, sure.
angle, we call it beta. I'm not splitting that in half. Let's say alpha, this is also alpha. Does that make sense? Because
Why is it also R? Oh
that's
wait.
two radius. That's isosceles, right? This one is alpha, the one must also alpha,
Oh
right?
right. Yeah, sorry. I
So
saw
same
this.
thing. This is beta, this one must be beta too, right?
Yeah.
So as this is external, at this angle. Let's say this angle is gamma 1. Gamma 1 is, since it's an external angle, so it's going to be 2 alpha. Is that it? This angle. That's an
Because
external.
it's an external. How do you prove this? I don't
Oh,
understand.
external angle is the sum of the two not adjacent angle. Do you remember that? I can prove it. This angle plus this is 180, right?
Yeah.
But this 2 plus that is also 180, so they must be the same.
What? Sorry. I don't.
Let me just draw
I don't
right
quite. Oh, so
Ang
this one and this
angle.
one plus this one equals 180, and this
Yeah.
plus this one also equals 180. So
Again. Let me just write
okay,
it.
so it's 2 alpha. So, but isn't alpha like 35 split in half?
Well, let's just say 2
So
alpha
wouldn't it just be
plus
like 35? 5 again.
well, not yet, because alpha plus beta is 35. It's okay. In the end, it's very easy, but now I'm just
What?
proving it.
Okay,
So
okay.
let me just write it all the way. ROE, that's 180, right? And then alpha plus gamma 1, because that's one, this is one straight line, so this is also 180. So that's why, wait, oh, this is not this one. Gamma 1 plus ROE is also 180. So that's why 2 alpha
No,
must
I
equal.
know. I understand that,
Oh,
but like,
okay.
isn't 2 alpha just 35 because alpha is 35 split into 2?
No. That's not it. Because alpha plus beta is 35. See?
Yeah.
But they're not the same. Alpha and beta are not the same. Does that make sense?
So what is alpha?
Well, alpha is just I draw it in here, so it divide that the whole angle in 2 angles. It's just one of the angles, and that's the
I
other
know,
angle,
so
beta.
what's the numerical value?
Beta. So this is beta. So this is also 2 beta. See that?
Yeah.
So now I can just say 2 alpha
Oh, it
plus
equals
2
2.
beta. Now is
Which
your 2
equals,
times
it equals,
35, right?
okay. Yeah, that makes sense.
Yeah, but we don't really
Alright.
do that in the test. This is me
So I thought you
proving
meant
it.
by R1, I thought you meant like the whole angle, so I was confused. But
Okay.
yeah, so it's like 70. Okay.
So, but we don't really remember a theorem like that. It would take a little too much time. So what we will try to remember, the theorem is basically called central angle. This is called central angle, right? For the same arc, DE, the central angle is always twice times the inscribed angle.
Yeah.
Do you remember this?
Yeah,
Yeah, we
yeah.
just proved it, right? But basically, you just time 2 for
The
35.
what, can you define the inscribed angle?
Oh, inscribed angle is basically this. If I have a circle, if I have any arc, just say any arc thing. This is the arc that I have. And then I can find any point. not on the arc, of course. Not on this arc. Any point on the circle. This is called inscribe angle. This angle is called inscribe angle.
Oh, I see. Yeah, and then the central angle is like
Yeah,
from
then the center
center.
angle is in here. It's
And
always
that's the central angle.
yeah. It's always
Yeah,
going to
I
be
see.
double that. We can prove it. We just use a little time to prove it. Does that make sense?
Yeah, that makes sense.
So you just have to memorize this. Otherwise, you have to prove it. That's takes a little time. So center angle. This is actually kind of easier. This center angle looks exactly, but this one is also this one. If this one is alpha, this one will be 2 alpha, right? Because they are having the same arc, right? They have the same arc. In the same spirit, there's also a little theorem is, for example, if it is the same arc, we say the same arc. So all this kind of inscribe angle, they're the same. See? That's one of the things about the circle. See? They have the same arc,
Yeah.
right? All
Yeah,
these
I
are the
see.
same. Yeah.
Yeah, I see it. Okay.
So this is one of the theorem you have to memorize it. It's also in syllabus. This is
I think our time is over. It's like 1:11.
sure. Let me
20.
just that's quite a few questions. You can finish this one, right? And you can, if you want to do geometry problem, you can do geometry problem first, but maybe all the questions, and then I can maybe know more about where is your weakness. Is that okay?
Yeah.
Okay, that's
Yeah.
it. And also, there, do you have time like to do a little? There's a website. They have the newest SAT. Let me just get
Yeah,
the-
you can send the link in the WeChat group chat, and I could try to
Do
work
you
on
know any Chinese? Because this is actually a Chinese website. Of course, the test is in all English. Do you know Chinese? That's my question. Some of
I
my
do. I know some, but I'm better at like speaking it than I am writing it.
yeah. This is I'm gonna send it later. But if you have problem, you can just log in that stuff, and if you have question, you can ask your mom, right? Just you can get a record. They have the good things. They have all the newest SAT. So you can just do one, right? So 2 part of the homework. You can do the document that I send you, but you can also do one SAT math. Does that make sense?
Yeah.
I'm gonna send you the
Okay, so I
website.
do like the document, but I also do the SAT website.
Yeah. For one
Okay.
document. Let me just show you, walk you a little there. Do you have time?
It's fine. I can just look at it later.
Yes, but if you have problem, you can just ask me in the group. Okay. I really want to
Okay.
use that website.
All right.
Okay, that's it then. Let's go.
Yeah, thank you. Bye.
Bye. 1, 2.